Oh, do you want the mic?
Oh yeah, where's the mic? I think it's right here. Oh, here we go. All right, so we're gonna start now.
Wait, I don't know if
Is it you on? I think it's on.
Is the mic working?
Yeah.
Oh, it is? Okay.
Yeah.
Gotcha.
Okay. All right, so today's lecture is we're going over databases. So before we start, some administration stuff. So PA2 should was due last night, and you guys should have turned it in unless you emailed us privately. We recommend you getting that done as soon as possible because PA3, which was just released and is due Sunday, is building off on that. So it's to your advantage to try to get PA2 done as quick as possible. In the future, if you need an extension, let us know at least 24 hours in advance. We are pretty lenient and flexible, and we want you guys to learn, but when it comes to these assignments, please let us know in advance if you can't make the deadline. And then grades for PA1 will be out soon. All right, so here's just some of the topics that we're going over today. So first, we're just gonna talk about what we learned so far. So for PA2, you were able to set up a Flask app backend that runs a server, and you can display hello world, or in your case show different tasks. But what if we wanted to display non-static data? So I think many of you guys have noticed that if you're running your task server, that after you close it, the data doesn't persist. If you start it again, you kind of start from scratch. But today we'll go over how we can fix that. So today in any sort of kind of meaningful app, there are different entities within it, and there are different relationships. So for example, Facebook, you have all these different users, and there's relationships between them, whether it's friends, you can do, in addition, there's photos, posts. So there's all these different entities, posts, photos, users, and there's all different kind of relationships between them. So databases allows you to store all these different entities and make said connections between other entities. So what is a database? So a database is basically just a collection of information that can be accessed, updated, or managed. So you can think of them, so a database is basically a bunch of tables together. And each of these tables, if you think about it, has rows with corresponding values. So you can think of it as if you have an Excel spreadsheet, you can have tables in those, and each row has a bunch of values associated with them. We'll go over some examples to make this clear. Okay, so say we wanted to design a database for a grocery store. So some example tables that we could have include fruits, vegetables, basically different things that we can take inventory of. So if you look in here, we have this table, and you can see the top row indicates which of these, which values in the each what the titles basically indicate what values the columns hold. So the first one contains an ID, which is a unique auto-generated value, kind of in PA2, each of your tasks had an ID and each of your comments had an ID. And then next we have name, quantity, price. So this is basically what a basic table would look like in a database. And then another thing that each of these values has is a type. So you can see that in everything in the name column has a type string, everything in the quantity column has type int, and everything in the price column has a double or a decimal value. Does anyone have any questions so far? Great. So why use a database? So a common question is why can't we just store it in a JSON or a text file? Because setting up a database has a lot of overhead, and sometimes it's much easier to just open a file and write this stuff to. So why is using a database better? So one of the main advantages is that you can query data. So later we'll go into SQL, which some of you guys might have heard of, but basically it's a language that lets you interact with the database in a very easy and intuitive way. So say if I had my fruits table, like what if I wanted to see like which fruits were in stock? And this is extremely helpful for larger data sets because databases do a lot of optimizations and indexing on its own versus like if you had like a text file, like to figure out like which fruits were in stock, you would have to like kind of parse the text and then like go through everything. Some other reasons is like being able to look up data much faster. One of the biggest reasons you use database is because of performance. Another one is like all your data is structured. So for like, as we saw earlier, like the column names specify like what values must be there. So you make sure that all your data is like uniform and follows like a single like form. Yeah. Other things is like database can scale well, and then you can also relate data from two different tables. So like in databases, you can have multiple tables and you can basically ask questions using both of them. So if I have a table of like users and a table of posts, I can like say like, given this user, like what post did they make? So it basically allows you to relate data in different ways.
Oh yeah, no, like adding on for the structured thing, I think like something that might help to think about is, so like going back to the JSON example, one of the reasons why it's kind of annoying, or like even though it's stored locally, which technically has like really fast accesses and like reads and writes, right? Because it's all stored locally, while a database usually you're hosting it somewhere else. So like for example, if we had a JSON and then like going back to the fruits example, maybe we have like a fruit here and it's, I don't know, maybe like a name and it's like apple. And then we have like an ID, and this is one, and then maybe we have more. One of the bad things about this is like it's not structured in that there's no guarantee that basically like entries in the JSON will follow the same format. And that's really, having that guarantee is really nice because, for example, if we're designing like an API and we're returning a list of fruits, like the client is basically guaranteed by the database. It's sort of like a contract formed by the, like however you choose to define the schema, which is sort of like the fields and the columns that you have. And then because of that, the client doesn't have to do any like guessing. Like, oh, like, am I guaranteed that when I get one of the fruits in the database, is it always going to have a name? Like, can it have more fields? If that makes sense. Does anyone have any questions regarding that? Very awesome.
Yeah, so we talked about a lot about like relating data, but that's kind of hard to visualize. So like, what is like a relational database? So like in the most general sense, it allows relationships between your data. The most popular, so there's different types of relational databases like MySQL, Postgres, SQLite, and then some other ones. We're going to be using SQLite later on, and the demo will include that. So like here are some examples of like why a relational database might be useful. So like if I have a user table, how do I show if two users are friends? And then going off of what I said earlier, like if I have a user in a post table, how do I keep track of who posted what? Okay, so we have an example about like a database for a blog. So like if we want to create a database for a blog, the two like important tables that we want to keep track of are the users like signed up for this blog and then the posts that are created. So we can see that each user has their own ID, a name, and a username. And a post table has also their own ID, a text, and then an author field. So what the author field refers to is the user who created that post. And in this case, the author field refers to a user ID of the user that created it. So the author field in this like post table is what we call a foreign key, which basically is a field in one table that uniquely identifies a row of generally another table. So in this case, the author is a foreign key which points to the user table. Does anyone have any questions about this? So there are different types of relationships when you have databases. So these are like the ones. So one-to-one means a row X in table A is related to only row Y in table B and vice versa. That probably sounds pretty confusing, but if we think about like different examples, so like Cornell students to net IDs. Every student only has one net ID, and one net ID only corresponds to one student. And then here are some other examples, like countries to capital cities, peoples to driver's license, and U.S. citizens to social security numbers. So basically, U.S. citizens only have one social security number, and one social security number belongs to only one person. So that's what we mean by one-to-one. Does anyone have any questions about this? So next is one-to-many. So a row in table A can be related to many rows in table B, but a row in table B can only be related to one row in table A. So like, what does this mean? So kind of like our previous example, one example is users to blog post. So a user can make multiple posts, but each post can only have one author. So that's an example of one-to-many. And here are some other ones, like authors to books, albums to songs, to-do list, to-do items. And then the last one is many-to-many. So rows in table A can be related to many rows in table B and vice versa. So a good example is like post to hashtag. So like when you create a post like on Instagram, you can have many hashtags in your post, but then if you click on that hashtag, a hashtag can have many posts associated with it. So that's like what many-to-many, and then here are some more other examples, like an actor can be in many movies, and a movie can contain many actors. Does anyone have any questions about database relationships? So what is SQL? So SQL stands for Structured Query Language, and it's basically how we interact with the database. It's basically this language that lets you, talk to it, like reading, inserting, updating, or deleting database or data from a database. So the word query is kind of thrown around a lot. So queries are basically kind of questions that we can ask the database. So like if we have questions like the ones I mentioned earlier, like which fruits are in stock, we can basically write these questions in SQL or SQL. And it's like a language like any other program language. It has keywords, syntax, and we'll go over some sample queries later. So why do we need SQL? So basically, this is, like I said earlier, this is like a way that we can communicate with the database. It allows us to alter or read data. And there's like many different complicated queries that you can do. So it's like very open-ended and is a good tool for interacting with the database. So I mentioned earlier like SQL or database management systems. So the one that we're going to be focusing on in this class is SQLite. SQLite is an RDBMS, and like a relational database management system basically allows you to create, update, and administer a relational database. So SQLite is unlike MySQL or Postgres, it's very lightweight and easy to set up. There's no installation or config necessary, and it's serverless. You don't need like a server running to have this on your computer. So how SQLite is different is it basically stores everything in like an ordinary disk file. Not necessarily like a text file or a JSON that we saw earlier, but like a binary thing that it writes to and can optimize. So basically your SQL database is all contained in a single file. So some pros and cons to this is it doesn't rely on a server to run, it's very lightweight, and because it's file-based, it's extremely portable. So if I created like a database on my end, I could send it to Young and he can open it and basically see the same things that I do. Some cons is not all of SQL queries and syntax are supported. It requires a lot of memory to run for large databases. It doesn't really scale well. And there's no like user or privilege management. So now we're gonna go into some SQL syntax. There's a lot covered here, but I'm gonna post a PDF of like the following slides so you guys can reference, because this will be very important for PA3. And then after this, we'll also walk through like a demo, like actually writing this. So how you would create a database, basically in your command line, which we'll do later, This is basically just syntax. You do SQLite 3 and then whatever you want to name it, .db. And basically this second part, so like blog.db, if I wanted to create a blog database, and basically you will see after you run this that there's a file called blog.db, which contains everything in your database, the file that basically contains it all. And then once you're in SQLite, this is how you view all the databases. Okay, so one of the most commonly used queries is like, say you want to create a table. So basically it follows this syntax. You usually say create table, whatever you want to name it, and then have this, this tuple indicating the column name and the data type. So, so common data types that are supported in databases is like, int, big int, which is like a long, if you guys are familiar with Java, decimal or like a double, and serial, which basically auto increments every time you insert a new row, but you won't really have to worry about that. Some others is mostly we use text. If you want like a fixed length in your database, you can use some of these other ones. And then Boolean, you can do timestamps or like just the date. So back to creating a table. This is what this basic syntax looks like. So say we wanted to create a table called users. So we indicate the name on the very left-hand side, so ID, and then we want the ID to be an integer. And then you indicate a primary key, which basically you're saying like, hey, this value is going to be unique for every user. And then you can also specify auto increment. So like in PA2, when you wanted to create a new task, you had to keep like a task ID counter. Or in our demo, you had to create like a task ID counter, and every time we wanted to create a new task, we had to increment it ourselves. So databases will actually handle this for you, so you don't have to like keep track of an ID and like assign it to it every time. And then the three final fields, we have name, and age, and text for the name, and then we can also specify that like names are always required in this for users, so we set that to not null. And there's all different types, like data types and things that you can specify, kind of like the not null flag. And yeah, but you don't have to worry too much about that. It's there's like many different ones. So if we go back, so like this is how we would create our users table in this example. And if we go back, we remember that for post table, we have this field author, which refers to a user ID, which is considered a foreign key. So how do we create that table? So again, post would have an ID field very similar to users. And so if we see we have this author int field, which refers to our author ID, and then you say it's required. And then how we say that like author refers to isn't just like any random int, it actually refers to the users table. You say like foreign key, and then you specify which field is the foreign key. And then you say references, and then the table that key references. So it references the users table, and then it references the ID field in that users table. So that's what like this users parentheses ID means. Basically saying, yes.
Oh, sorry to interrupt. So this table posts is within the database that you've already constructed.
Yeah, exactly.
And that table refers to the posts by one person.
Yes. Okay. Yeah. So if you think about the hierarchy, we have our database. So like in this case, I think it was blog at the very top, and then within that database, we have different tables. So we have like users and we have posts. And what happens is like, because all these tables are in the same database, we can refer to each other. If these tables were in different databases, we wouldn't be able to do this.
Wait, can everyone do like a thumbs up, thumbs down of like how they feel with everything that we've talked about? Yes. Sure.
Do you have any questions?
Yeah. Do you have any? Do we want to? Okay, so I can quickly go through like everything we've gone over in like a TLDR.
Yeah. And like this syntax isn't like very important to memorize at all. Like most of the time you're just kind of Googling like SQL syntax, like how to do this. This is just like a very basic overview of like what this stuff means. So you don't have to worry about like writing all this down or anything.
Okay, so I think like the way to think about it is like currently with PA2 submissions, we have like a global variable for like posts or something. But then some of the cons that we found are like, okay, this leads to, we lose the data after every single time like we kill the app, right, and rerun it. So the solution, like the most intuitive solution, is to store posts in like a JSON or a text file, right, to have it persist on the hard drive. So maybe we iterate to that solution. So instead of having posts be some variable that we define at the top of our file, we define it in like a posts.txt or like a posts.json or something, which would be the same thing. But then some of the problems with this is that we don't really have guarantees on how the data format is stored. Like optimally, we want to kind of reduce the number of human errors here. So if I accidentally forgot a field that I wanted to add, or like something that's really common is like, oh, if I'm writing to a file, maybe I write like a dot like name, but I mistype name. So it's like NAMR or something, right? This is a pretty common error. But then if I'm just writing this field to a text file or a JSON, there isn't any error handling, right? Like, oh, hey, you misspelled this. Like NAMR is not a field in your database, right? So if you think about it, so we add this new layer, the database, and this solves a lot of the problems that we have with the text file, right? And some of the other problems that we can think of are like, okay, so let's say we have, so let's see, something that we might want to do is have multiple servers share the same data source, but that's not really possible if we have a text file. Like when we replicate that same text file across everything, like optimally we would want this in somewhere that's decentralized, like away from any of the code that we're running, right? Lives somewhere else. And turns out a database solves all of those problems for us. It basically allows us to, all the database is doing is letting us define the format that we want to store our data, right? It's not doing anything else. And the way that we query or get information, how we put information into that database is through this language called SQL, right? Which just stands for Structured Query Language. And then that's what we're basically doing here. Does that make sense? So like, I think it's really important to like understand why we reach these decisions. It's like something that we talk about a lot in the course, like kind of understanding why we have databases instead of learning like, oh, we have databases, but like, why do we actually use them, right? Like, because if you don't know, then it's kind of difficult to understand like the whole purpose behind doing that. Does that make sense? Yeah, so the queries seem kind of, okay, so we can also talk quickly about like foreign keys. So in databases, the way that we define tables, like Megan mentioned, is through tables, or the way we define objects is through tables. So say we have like users, and I don't know, we have like a name here, and we have an ID, and we have posts, and maybe we have the same thing, I don't know, like content, and an ID. But for us, if we want to have this notion of, oh, like a user made a specific post, the most intuitive way for us to do that is to add a user ID field here, right? So like if we know that user 0 corresponds to user young, and we want to say, oh, this post corresponds to user 0, the easiest way to do that is add like what's called a foreign key here, and basically, well, here it's author, but basically it's saying like, okay, here's the name of it, so maybe we can make this more accurate. So let's say this is author. So the name of the field that we're defining is author, and this references this field. So like this, so it's sort of like making another like invariant, right? Something that is maintained by our database. It's saying that the author field in posts must reference a valid user ID. And in doing so, it prevents us from like accidentally assigning this author field to a user that might not exist in our database, right? Does that all make sense? Yeah, what's up?
So that foreign key line instructs it to grab a user ID and put it in the author?
It's just saying like this is what the field represents. So if you like, if we look at some of the other lines, like text is, so this, it's like the left side is the name of the field. So it's like the name of the field is text, and then what that field contains is text that is not null, so a non-empty text string. Yeah. Any other questions? Yeah, so.
So in SQL, how would you implement what we were talking about before regarding like relationships of one-to-one, many-to-one?
Oh yeah. Okay. So here, if we look at this, this is like sort of like obviously one to many, right? Because like we have one. So for example, like if we were to fill in the content of this database, wait, I erased the wrong thing. Okay, it's kind of unlucky. But let's say we have posts, and then so we have posts, and then we have one user, user 0, and then maybe we have like hello and 0. I'll omit the ID field. So hello is the post, and maybe this is the ID actually. Okay, that's the ID. And then we have a new post like goodbye or good or something, and this also references 0, right? And then one-to-one and many-to-many are more tricky. Let's see. Do you cover it later?
No.
Okay. For one-to-one fields, there's another invariant that like, okay, so we have an author, and then we have a corresponding post, and those must refer to each other at all times. And that's another invariant that's enforced by the database. Does that make sense? So like, for example, we could have 0, and then maybe if these are one-to-one, we also have like a post ID over here. So I mean, these are obviously not one-to-one, but that's how you might implement it. And then for many-to-many, you have a separate table. So for example, something like users to posts, and then this stores a user ID, and the fields that this has is a user ID and a post ID. So it would be something like that. So you have a separate table to store the contents of that. Yeah. Because you can't, okay, yeah. You can there.
Wait, a little time for the demo. Yeah, so this is some other SQLite stuff. This will be posted, so you don't have to worry about this. So like if you want to insert a row into a table, this is generally what it looks like. You specify the table, which the columns that you're inserting, and then the values corresponding to that column. If you're like inserting values into all of the columns, then you can omit this part. So an example, if I have a user table, I would say, hey, or that previous user table we defined had ID, name, age, email. We don't have to specify ID because that auto increments every time. And then we say we want to insert name, age, and email, and then we provide the values. And then say we wanted to create a post. So in this case, we have our foreign key author, and we can see that in this case, we put in 1 as the value, like assuming that like the user that we created before, that my user had an ID of 1. So this is basically just how you insert values into tables. Yeah. So how do you read data from the database? So basically you use this keyword called select, and then you specify which columns do you want from this table. So like say I had my like post table and I only wanted the contents, I could do select contents from posts. So, but if I know that I want all the columns, then I can just use this star syntax. And this is probably one of the most common queries that you will use. So yeah, if I want to get all the users, that's what it would look like. If I only wanted the name and the email of all users, then I would use this syntax. And then say like we wanted to ask more complicated queries where we have some sort of condition. So it's pretty intuitive. Basically, you just say like select whatever from users where, and then you can specify like a field. So like in this case, we specify like the age is greater than or equal to 18. In the where clause, you can always refer to the column names from like the table that you're referring to. So if I did select star from post, I could do like where like contents, like the length of the contents is like greater than like 50 or something. Or like, okay, so like, yeah, this is, if I wanted to get the post of author with ID 1, I would just do basically that query and it would get all the posts that this author created. And then you can also use and ors in your condition. It's like fairly intuitive. So like where I want to get the post where the author is 1 and the ID is 1. And then update is pretty similar to like inserting values. So basically you specify the table that you want to update. And and then which values want to change. So a very common one is if I wanted to update my email, I would say update users and set the email field equal to this. Because let's say I didn't want to update any of the other fields, I can just say this. And you can also update multiple fields at the same time. And then you can also delete values. So it's pretty similar. You have the condition again. So this would delete post where the ID is equal to 2. So it's fairly intuitive and pretty easy to read to figure out what each of these queries mean. If I wanted to delete a table altogether, I would just use do drop table and then whatever table name. And then if I actually wanted to delete a database, this is the syntax. But this is something that's not really important and that you probably won't use. So I posted a link on Piazza to a Git repo if you guys want to follow along with this demo. The completed code for the demo will be pushed after lecture, so don't worry if you can't follow along, because we're running a little low on time. But okay. So if you clone this repo, we look here and we can see that I basically just put in the same app.py from last week, but we're going to change it to use a database rather than just storing these tasks in memory like here. So we can see that we have the app.py, and then I added a SQLite file, which basically is our to-do database, which currently is empty. And then we have this file called db.py, which is where most of the code will be written. So is this big enough? Yeah. Yeah. So first, I don't think it's installed, but we all need to install SQLite 3. So you can just do sudo apt-get install SQLite 3. It shouldn't take long. All right, so now if you go to your the demo source folder, inside we have the same things as before, and then you guys can take a second to set up your virtual environment. So if you don't remember to set it up, you just do virtual env and then the folder that you want to call it. Oh.
Interesting.
That's weird. All right. Well, is it not installed?
I thought it was.
I guess it's not. All right. So you can just set up your virtual environment. Fuck. This is not good. Why is Python not?
Oh no, it is installed. Wait. Okay. We have a solution to this. Can I see something? Can I see something?
Oh wait. Hold on. Yeah. Go for it.
Let me see.
This new VM.
One second.
Oh, do you have to do the flag?
Yeah. Wait, let's see. Okay. Nice.
All right.
Okay.
Does anyone have any problem setting up their virtual environment? All right, cool. All right, so then we can activate it and then install our requirements. All right, so now you can open this folder. You can open this folder, and we'll look at the code. Is this it? Can't tell. Nope, this is the complete version. All right, so like before, we have our same app.py file, and then we have this db.py file. So basically, what this does is it sets up our database for us. So if you're more interested in this, you can go to this link, but basically what this ensures is that there's only one database object at a time. So if we look in our init function, we have this SQLite.connect, which basically tells us like, hey, our database is todo.db, which you can see is right here. And it basically connects to that, and anything that happens subsequently will be reflected in todo.db. Yeah, so our first thing is we want to create a task table. So how you can how you can run SQL syntax within Python is, so first we want to do like a try, and then you basically do self.con, because that refers to basically our DB connection, and then we can say execute this SQL statement, and then we do this like this basically indicates like it's a multi-line string, and then we can do create table task, and then specify which fields we want. So we can say ID, integer, primary key. We can say a description, text not null, and done, which is a Boolean, and it's also not null. And then if we get an exception, we can just print it. Does anyone have any questions so far about what any of this code does? All right, cool. And then deleting a task, like if we want to delete our table, it's pretty simple. We do the same thing where we can just execute a SQL command and say drop table if exists. So basically just delete the table if it does exist, task, like that. And then, so if you look at app.py, our first route is to get all tasks. So we need a way to do that within the database. So we can just do, so basically I'm creating a variable called cursor, which I'll explain later. And then we want to execute select what?
Need to initialize the cursor. Oh.
No. Which basically runs our command to select everything from our table task. And if you remember, our get all tasks returned in app.py basically returned a list of all the tasks. So we can create a task list, which will give us the result. So basically what cursor does is it returns basically this 2D array of all the rows in this table. So basically we can do this for loop, like for row in cursor, where each row corresponds to a single entry. And like the array of this row, basically, so like in this case, we have 3 fields, right? ID, description, and done. So for the first index in the row, it's going to contain the ID. The second is going to contain the description, and the third is going to contain done. So basically how we can create our task is we can append, and we can say ID is equal to the first element of this row, description is the second element, and done is third element. And basically this is the order in which you define this up here. And then we can just return all tasks. Yeah, so now if you go back to your app.py, we can see that, so basically we can delete this now because we are no longer storing our tasks locally. And we don't need to keep track of like an ID count or anything. So you can see up here that I actually imported DB and then initialized an instance, so which creates an object of the class DB. So instead of referring to our old list, we can just do db.get all tasks. So yeah, does anyone have any questions so far? So next, if you look, our next method is to create a new task. So we need a way to insert a task object into the table. So we can see that this method takes in a description and a done field. And so we can do something. So first I'll just explain this after, but, and then we can execute, use the insert keyword into task, and then the fields we want to insert, description and done, and the values. And in this case, we have our description in done field, but we want to insert these into our SQL statement. So we can do this like question mark syntax like this. And then the second argument of this execute function is basically what you want those question marks to be. And it's basically a tuple value. So we want the first question mark to be the description that they gave us as an argument, and then the done parameter. And then afterwards, we have to do this thing called self.con.commit, which basically says commit this new thing to our database. And then we want to return. So if you look at app.py, when we create a new task, we also want to return that task to the user. So like we executed the SQL statement, but like we have no way of figuring out like what ID was just used to create this task. So we can do this thing where we create this cursor before and then execute this, and then it actually has a field called .last row ID, which basically refers to the last row of like what you just inserted. So that basically we know that this is going to return the ID of the task that we just created. This might seem a little confusing. So does anyone have any questions? Yeah.
So is it like last, like in terms of time, like this is the most recent row, or is it last as in like of the rows you selected, this is the bottom one?
It's like of the ones that you just inserted, like the query you just ran, or like the statement that you just ran. Yeah. Yeah, what's up?
So the execute syntax where you had that description, comment, done thing, is that those values go in question mark, comma?
Yeah, so
Yeah.
it's like a format string,
Okay.
if you're familiar with that.
Yeah.
Does anyone else have questions?
I guess why necessarily would you do that, as in like having the description and done after putting the question marks? Why not just put them directly into?
Oh yeah, sure.
Oh, like why
Yeah.
use the question marks rather than like
why are the
concatenating?
question marks initially, right?
Okay, sure. So I think like you mean like instead of doing it like that, having it like string, I don't know, like a plus the variable plus like another string like this. Is that the question? Like why don't we have this instead of that?
Yeah.
Okay, sure. So first, I think this is more readable, especially if you have a lot of stuff that you're inserting. Second of all, there's this thing called like SQL injection, where you can, or like malicious clients can insert values into here. So for example, if you didn't have that, maybe like you could put a semicolon there, terminating the previous statement, and then you could have like drop table. If their description was semicolon drop table tasks or whatever your table name is, then if you didn't have this, then it would just execute both of those statements and then you'd lose all your data, right? But then one of the things that SQLite provides is this cursor object that has like prevention of that built in. Yeah, so those are the two answers.
So if we go back to our create task, so like basically are we going to change this to reflect our new methods? So we don't need this task ID counter anymore, but we still do need our the parameters that the user set. And what we could do is instead of our ID referring to the task ID counter, we know that our db.insert insert task table, we know that this creates a new task with our parameters and returns the ID of what we want. So of the new task. So this would return the new ID while at the same time making the new entity in the database. And then we don't need this anymore or this. So that's basically our new code. As you can see, it's like cleaner. We don't have to worry about this like ID variable. So now if we get back to here, how do we get a task by ID? So this is basically like a select statement with a condition. So we can just do, we can have our cursor again, similar to how we got all task. And we have our execute method that we call again, and we can do the select star, which means we want all the fields from task where ID is equal to our question mark again. And in this case, so the second argument of this function is always a tuple. So how we say it's a tuple is we do like the parentheses and ID, but there's some weird things where if you have a single element of a tuple, you have to like put a comma at the end to specify like this is actually a tuple. I forgot what happens if you don't have it, but it doesn't think it's like a tuple. It's kind of weird, but.
Oh, you guys should watch out for that, because like.
That's like a common mistake.
This will like cost you hours of your life if you forget the comma.
Yeah.
So just please remember
add the comma.
Put a comma.
Yeah. Like I had this issue when I was setting this up actually. So, okay. So like as we said before, like when we run these select statements, it actually returns like a 2D array of all the rows that match our condition. But we know that there's only one row where the ID is equal to our given one. But so we still have to do this for row in cursor kind of syntax. But we know that the only row in there is going to be the actual task. So we can do the same thing where we return ID row. So what if we don't find the task? So what happens is if we don't find the task where ID is equal to our given one, the cursor will actually be empty. So this for loop will actually be skipped. So in this case, if we don't find it, we're just going to want to return none. So yeah, if we go back to our app.py, we can see in get task, before we checked if our task ID was in task, but what we can do directly is just say task is equal to db.get task by ID and the task ID. And we can basically say that instead of this, we can say if task is not none. So if the task does exist, we don't need this, then we basically return it, or else we can just keep our same error statement. Does anyone have any questions so far?
Do you want to demo this part?
Yeah. So yeah, I'll demo this. So let me comment out these routes for now. And we can do Python. Oh god, what is this? Line 12. All right. So yeah. So now if we open up Postman,
does anyone have any other questions in the meantime? Yeah, what's up?
Is there a difference between is not none and like does not equal none?
Yeah. Well, wait. What do you mean by is there a difference? Like, is there a difference in like what is like what the result could be?
Yeah.
No. But it's like if the Python has like a style guide where it's like the creators of Python were like, this is how you should write code, and they want you to use like the is keyword as much as possible. It's just, yeah, but there's no difference.
yeah. So in this case, we can get all tasks, but there's currently, oh, what's this? Oh, okay. Oh yeah, one thing I forgot to do is in our init function before we use this create example table, but every time we init, we want to make sure our task table exists. So we can just call self.create task table. If it already exists, it won't actually do anything, but if it doesn't, then it will run this SQL command. So if we start our serve, I think it starts again. We can run this GET request, and we see that it's empty. Say we wanted to create a post or a task. I think it just said, yeah. We would post this, and we see that it's automatically assigned ID 1. And then if we want to get all task again, we see that it's there. So one thing that you'll notice is like if you shut down the server and you start it up again, this will actually still be there. So you can actually, so like I mentioned, you'll see in the slides from previous, like the SQL syntax, that you can, there are different things that you can do with SQLite. So I can actually open up this this database. So I can do SQLite 3 todo.db, and then I can do .tables, and it'll show me that there's this task table here. And if I want to see all the values, I can just do direct SQL syntax. So select star from task, and I will see this task that I just created. And like the server isn't even running, so you can like see this data even when it's not live.
Wait, this is a great way to debug your code and see if stuff is actually being written to the database or not. Because like sometimes it's unclear whether that step is even happening. And some other note is like the select and like from keywords, it's in general you capitalize the keywords for SQL, but it's not necessary. Yeah.
So yeah, we can quit that. So going back to our code, what was the last one? Oh yeah, the next two. So if we wanted to update a task or delete a task, we can just do, yeah, so updating a task is pretty simple. You just execute this SQL command. We can do update task, and we want to set the description to this question mark and done to some question mark, where ID is also equal to some question mark. And then we can specify which values those question marks take. So in this case, description was first, and then the done value, and then the ID. And then one important thing is you always have to remember when you're updating or writing something that you have to do this commit. Call this commit, which basically commits the entity that you're updating. And then we'll just do delete real quick. So you can just do, so say we want to delete a task by an ID. It's pretty simple. Delete from the table that we want. So in this case, task, where the ID is equal to our given parameter. And in this case, we want to do ID, and then don't forget that last question, that last comma, and then commit. So now we go back to our app.py. We can uncomment this. So for our previous update task, we checked all these things, but we don't need to. We can just say, so we still need the post body. We can extract the description by just changing this, and the done field. And in this case, we want to call db.update task by ID with our task ID, the description we want to change it to, and the done. And then what actually happens is, like, say we wanted to try to update something that wasn't in the database. So when it runs that like where condition, like where ID is equal to something, if the database doesn't even find that post with that ID, it won't actually do anything. So we don't really have to worry about that kind of behavior. And then we can get our new updated task by doing db.get task by ID. And then we can say if task is not none, then return that new task, or else return this like not found error. And then delete task. So before we checked if the task ID was in task. So and remember that this endpoint actually returns the deleted task. So we want to actually find that task before we delete it. So we use that same get task by ID. And then we can basically say if task is not none, so if this task does exist, then we want to call our delete function, delete task by ID, and then return our newly deleted task, or else return this not found. Does anyone have any question? Anyone have the questions? Yeah.
So like here you're always updating the database and like every time a parameter is changed, but like say you had like a game where you had like a user score that was like updating like very quickly, like would you always update it to the database like every time the score updates just by a small increment, or could you possibly set it up so that like bigger increments are handled as opposed to just a small increment to make it more efficient?
Are you talking about like if you get thousands of requests at a time?
Yeah, basically.
Well, basically right now what we're doing is like Flask, you can probably set it up that way where you can cache like how many increments you get. But for like our case, like every time we call, like we make a request to this endpoint, this method will be run. But there are different ways that you can do optimizations like that. But for now.
Also, like to answer your question, I think like with a lot of like popular video games nowadays, like something like what you described as an issue where like each client under a server has its own copy of the data that's being processed, right? And that all needs to be synced with the server, and then the client fetches a new update. But with like how fast computers have gotten recently, that's just like not, it's like a non-issue basically. Like internet speed is not really a limiting, like the number of requests that you have to make isn't a limiting factor anymore, which is why like servers can handle like hundreds of players running the same exact game at once and still handle like all the database transactions. So it's usually not actually cached, to answer your question. And it is like the database writes are still done because it's less expensive than like storing everything in memory. Yeah.
So that's basically it, because like we're almost out of time. Yeah, so that's basically it. I'll push this code to GitHub, and I'll post the PDF with all the different syntaxes, and then the video lecture should be up by end of tonight. If anyone, if you guys don't have any questions, you guys can go.
I updated the new image.
Okay,
You might want to tell people.